Hey guys, how you going? After a few days, maybe weeks, I'm back here. One friend of mine asking me to explain about thresholds. He is not from this IT or technology or deep math things. So I think it makes sense to explain to for people just interested in the area and in the team. So let's go. When we talk about thresholds, it's like a function that activates only above certain points. I know I already told that in the my blog post, but I think I'm gonna try to explain with my notebook that I made some drawings here. Like, let's try to train a model to recognize if it's a addition or subtraction. You know, in an image with 90 pixels, 3 by 3, so 90 pixels. If, let's consider the pixel have to be activated or deactivated, not medium term like grayscale, okay? Just 0 or 1. I know you could just make a function using the pixel, but I think this makes sense as a base and you can like generalize for bigger situations and more complex. So let's go. In the case of addition, you would have this mask. And when I say mask, you can imagine it like a matrix that will match the first pixels with the first pixel from here, the second with the second. So the nine ones have one pair in this weights matrix. Because this will be the weights, like the way we actually give some importance for some pixels or others. For example, in addition, let's one page, um, one more thing before the addition. You can see that the edges of both of these representations are never used. So we can imagine that would be equal because it's like doesn't matter if there is a data there if it's one or zero, it's one or zero because it shouldn't be there. So any data in there would be noise because if for the addition and for the subtraction, these edges don't matter. So let's imagine it like equal operator here. So in the end of the function, it would be zero, for example, because it doesn't matter. But in addition, we have this second pixel and this pixel from the left, this pixel from the right, and this pixel in below. That is really important. But at the same time, the pixel above and below is even more important because the minus don't have these two. So I put a plus sign here that is like more stronger roads than the other ones, and in the below too. So let's imagine it that the weight for this above and below is bigger. For example, if this pixel from the edge will be zero because it doesn't matter, these pixels in the middle will be one. This above and below could be like two because it's more important and the threshold function cares if the function is above some number. So in this case, we could say that this is addition, comparing these weights and this and so on. But let's go to the subtraction one. Here, we also have to consider that the middle above and the middle below, it's even more important because we are comparing with a situation with the above and below. It's a core information to say if it's addition because if there is not an above and below, it's a subtraction sign. If there is these two, it's addition sign. Getting back to the video, sorry for the cuts. It would be a minus here because it's a threshold function. So let's imagine that each pixel is evaluates as one. It's not the case in real life, but it's good for visualization, right? So this one that has the equals, we will consider zero because doesn't matter the information because in the edges, right? So in the total, we have one, two, three, four, five. Five information that's actually important. 5 pixels that can be 0 or 1. Here in the minus, we can actually make the threshold. For example, if it is a minus, it have to be 3 or more. So if these two data from below and above, above and below, is present, or the pixel is active, it's not a minus, because we know it's going to be addition or other things. In this case, we are just evaluation if one is a minus or one is or not addition. Okay? When I say minus is subtraction, sorry. So in this one, what would happen? The ones from the edge would be 0, and we want to make it above 3, for example. When we, if each one evaluates as 5, because there is 5 pixels, we have 3 here, but 2 with harder right and minus and above and below, because it means it's probably not a minus sign. So instead of this evaluation as 1, it could evaluate as -1, for example. Then we have 1 plus 1 plus 1. So 3 minus 1 minus 1. In the end, would be 1. The threshold will not be reached, because we want to be, for example, in this case, above 2 or above 1, because it means will be a minus, because we are just comparing it is or not a subtraction. So when we write this minus sign stronger, it's like we are giving a weight that's dimin- that reduce the threshold in the end. So it's 1 plus 1 plus 1, this would be 3, but the this one like try to drag down the total number to the threshold meeting. So it would not meet the threshold, and it would return that it is not a subtraction, a drawing of the subtraction. In this case, it's the same thing, but it's simplified, because every data here would be a plus sign. So we can say that like above 4, it will be addition, because if it's 4, it means one of the sides or one of the pixels that should be active is not, so it can not be a addition. So that's all. I'm not sure if it makes sense enough situation, but just to try to wrap everything up, we could create like two neurons that would say if it is addition and if it is subtraction, separated. And this is the case which the perceptron will not be enough, and the other line will also not be enough. That you can imagine it like the XOR plots here that I also wrote in the blog post, that you have two conditionals to actually reach what you need. Because if it's above something, it will don't work. If it's below something, the XOR also don't work. It's just like one area of the Cartesian plan. In this case, would be similar, but with two dimensions, which the output would be addition and the other output would be subtraction, like two separate neurons that activates based on if it is something or it is the other thing. In this case, it would not be so simplified like the 0 or +1 or -1 that I said. It would be something like random numbers, and the weights would be also random numbers that will be trained to reach the conditions you wanted. But it would also work. In the end, we'll have two neurons that, based on the activation of these two neurons, you can say that if it's one or another, or what's the chance of being one or another. Of course, there's more things to this, because you would have to make the these neurons binary cross entropy to be more precise, because binary cross entropy activation would be better for this type of situation. But it also works for the visualization and the intuition of these neural networks. I think it makes sense. If it doesn't make sense, please, for you that asking me for this explanation. And I think I can try to explain better, because this also helps my intuition to develop even more for explanations and these things. Also, thanks for my friends that's actually trying in helping me improve my communications and my explanation skills. So that's all. Thank you guys. Love you so much.